Oh, hey. Hi, guys. So I think we can get started right now. So hi, everyone. I'm Alex Ma. This is Michael. We're going to give you a nice talk today about monitoring production deployments. Usually we end up talking about just kind of the mechanics of monitoring and what's involved. And today it's actually kind of interesting because Michael's from LinkedIn and he's actually going to give us some real world practical knowledge. So today's talk should be a little bit interesting for you. So here's the agenda that we're looking at. It's really simple, right? We are looking at a couple things. First off, monitoring tools. And tools is kind of an overloaded word here. What we're looking at is all the interfaces that I might get monitoring data out of for my production system. And so most of it's going to center around Couchbase, but we're also going to talk about some of the aspects on the system that we want to get information from as well. Michael's going to spend some time talking about how to make sense of all this information because it is a lot of information. For some of the Couchbase metrics, we're talking about multiple hundreds of metrics. So what do you look at? What do you monitor? What's important, right? We're going to talk about some of those things. From there, we're going to look at probably the most important thing. All of these things are great if you're sitting there in front of the computer watching the system, but you're not always going to be doing that, right? 3 o'clock in the morning, something bad happens. You need an actual monitoring system to be watching this stuff, alerting you and letting you know what's going on. And we're going to talk a little bit about kind of how to take some of the knowledge that we talked about today, those endpoints that we talked about, making sense of some of that data, and how to get that into whatever monitoring system it is that you're using. We're not going to focus on anything really specific, but we're going to cover at a high level some of the techniques that have been used. And lastly, we'll kind of just wrap it up for you guys and end with some questions. And try not to go too long. I think there's wine or beer or something downstairs after this, so make sure you guys get down there in time. That hopefully there won't be too much of a line. So gratuitous headshot time. As an introduction, my name is Alex Ma. I'm a principal architect at Couchbase. And so principal architect, again, super overloaded term, but pretty much I do a lot of the things that a field engineer does. When I first started at Couchbase, I actually was one of the guys that was in charge of on-call production support. So chances are if you're using Couchbase 5 years ago and you're an enterprise customer and you called in at 3 o'clock in the morning with your system warming up or a rebalance going slow, I was probably the one that you talked to. Prior to that, I spent a few years in operations and DevOps, and then I went into a monitoring tech company. So monitoring and working in data centers, working around production systems is something that I'm fairly familiar with. I've seen a lot of deployments over the last 5 years. I work with a lot of the larger enterprise deployments for Couchbase within the US. So seen a lot of things that you should do and a lot that you shouldn't. So we'll talk about those as well.
So I'm Michael Keogh. I'm a staff site reliability engineer at LinkedIn. And I'm on the production SRE team. So my team is responsible for driving resolution and communication around major site incidents. The other part of my role is helping to support, monitoring direction and evangelizing, what monitoring options we have internally, and suggest to other teams how they can improve on their monitoring. I'm a member of something we call at LinkedIn CBVT, which stands for Couchbase Virtual Team. Our CBVT is a team of engineers who dedicate part of their time to supporting the Couchbase ecosystem at LinkedIn, whether that be operations or tooling development. We help build and sustain the ecosystem of Couchbase at LinkedIn. I've had in past talks people sort of murmur between themselves about what my accent is. It is Australian. Please don't mistake it for me being English. And you can reach me at Michael K. Keogh or Matrix Deck.
Okay, cool. All right, so let's get into it. We're going to start with kind of like I talked about, the interfaces, some of the ways that we're going to capture data or get data out of the system, whatever it may be. Okay. And so this is probably the one that is most familiar to you guys. This is the most common starting point. It's the Couchbase web console, right? And this is what a lot of people actually use for their day-to-day monitoring. And let's just be clear, this is a great system for getting a sense for what's going on real time in Couchbase. It's fantastic for troubleshooting. but it's not necessarily meant for real-time alerting and monitoring. For that, we'll talk about that in a later section. Okay, so for the web interface itself, there's a couple things, and the interface for this is pretty friendly in terms of you click on it, you get what you see. But there's a couple things to point out in terms of using it that some people may have skipped over, and we'll just cover a couple of those things, and we'll build on that knowledge as we go through the talk this afternoon. So first couple things, right? Here in the web console itself, you'll see a ton of different small boxes that show the timeline for a different metric. And here we're looking at the server resources. There's about 9 of them. That's followed by about another 20 or 30 summary resources. And things are organized by summary, vbuckets, disk-specific metrics, replication queue metrics, indexing metrics, and cross data center replication metrics. So for any of these, right, all of that information is available in that little chart. But if you click on the graph, it'll actually bubble up the larger chart to show that, so that you can see it at a higher resolution and get more information about it. Over here on the side is also another thing that's kind of interesting, right? This actually gives you some detail about what it is you're looking at. Sometimes it's a very short amount of detail, sometimes it's a good amount of detail, it kind of varies. But for something simple like this, ops per second, we get a description of exactly what that metric is, and more importantly for later on, what that metric, how it is measured and what it's comprised of. In Couchbase, for a lot of the metrics that we measure, a lot of them are not individual metrics, like CPU time, right? Ops per second is actually made up of multiple things, and for that, you'll actually see that it is measured from command get, command set, anchor miss, anchor hits, decker, it goes on, right? But it'll show you kind of what metrics it uses to formulate this derived metric, along with any math that's involved, okay? So some of these things are percentage-based, some of these things are any number of different formats, but it's rare that it's measured from just one thing. So this box, when you click on the metric itself, not only will it display it up here, but it'll also show you off to the side how you find more information about that thing, okay? And this is kind of a larger view of the summary section. Again, this is maybe a little bit more familiar to those of you guys that are actually tasked with running this stuff and watching it from a day-to-day basis. Michael's actually going to talk about this in a bit more detail about what they look at LinkedIn for what they consider important. So for now, we'll kind of hold this one for his section, and we'll continue on there, okay? One other thing, if you'll note, you see these little triangles here? So these little triangles, if you hover over them, it'll give you a screen that says show by server. And that's actually a really interesting option, because in this case, what we're looking at is generally cluster level metrics. What's the cluster's disk write queue? How many ops per second is my cluster doing? And for a lot of these things that you're monitoring, you're going to want to watch them at a cluster level. But for some things, you are actually going to want to watch things at an individual server level as well. So you want both the aggregate as well as the discrete, right? So here, in this case, what we're looking at is disk write queue. And particularly what we're looking at is the drain rate. And these numbers may be a little bit small, but you can see deviations between them, right? And so for things like drain rate specifically, drain rate and fill rate, disk write queue, those all have impacts in the system when they get to certain levels, or the variations get to a different height. So you'll always want to look at this kind of information at a discrete level on a per node basis, because you can have completely different performances. And I'll give you an example. Let's say we've got a RAID 5 configuration on all of these machines, and one of these machines has bad disks. We replace it and it's rebuilding, right? That's going to drastically reduce its I/O capacity. Now, while it's rebuilding, the cluster is sending it writes. It's sending all the nodes writes, and all those nodes are doing, they're writing those down to disk. Well, this one node, since it's, rebuilding, it is taking longer to write those to disk, which means that the disk write queue is going to continue growing while it's rebuilding. And so if it grows to a certain amount, certain things could happen in Couchbase. Right? So that is why you want to monitor these kinds of things at the cluster level as well as the discrete level as well. Okay. Number two, there's a bunch of things in terms of interfaces that we're going to talk about here, is the Couchbase REST API. Okay? And what we're looking at here is just, again, more ways to get information out of Couchbase, more things to give me more options. Okay? So the REST API is actually the authoritative place for any kind of administrative level action in the Couchbase world. Okay? And so what that really means is we've got this web console that you're using. That web console is just making REST calls. It's just making REST calls. It's saying, hey, give me the stats for this server. Tell this cluster rebalance, fail over this node. The REST is actually the authoritative place. So everything is handled at the REST level, and the web console just is an interface for you to access the REST console. Okay? And so through REST, what I've got here is kind of a link to the doc page for it, as well as kind of where this thing is located. If you go to the REST endpoint, pools, default, buckets, your bucket name, /stats, what you'll get is something that looks like this. Okay? Now this, I have a plugin in Chrome so that it represents JSON in a way that's a bit more manageable, other than just showing me a giant thing of JSON. But it shows it to me in like an Explorer tree view. So what I'm able to do is kind of see exactly what's going on in a bit more concise fashion. The REST API is going to show you a lot of the metrics, any of the metrics that you're used to seeing in the Couchbase web console. Again, because the two are very similar, right? The web console is calling into REST. And the way that it is designed to work from an endpoint status, you can see here there's something called samples, and then we have all these different metrics here, and what looks to be a large amount of numbers. Now, all of the metrics are available from this endpoint, and there's actually endpoints for XDCR, there's endpoints for indexing, there's different endpoints depending on what you're going after, but if you're just going after basic stats, you'll find them here. And the way that we organize it in the JSON is they're returned as all the available metrics and 60 measurements per metric. Okay? So 60 measurements is just kind of the default. Right? So what you're looking at is maybe the first 10 or 15 metrics for average background wait time. Okay? And this is something that is going to be represented in a very large JSON array, and it's something that you need to take consideration into when you start going, okay, I'm going to get this into my monitoring system, because this is a very large piece of JSON, and if you're working with a monitoring system that's very simple, like let's say you're using a Nagios, and everything you're doing is written in shell scripts, shell is not particularly fantastic at parsing JSON, right? So if you're working with something like Python and you can just navigate through the tree structure like this, then you might go, hey, no big deal, I'll just navigate to that object and I'll take the 60th measurement and use that as my collection for that metric, right? Whereas in Bash or Shell, you do unnatural things with grep and set and some other stuff, right? So again, this gives you options in terms of when you go to pull this into your internal monitoring system, but it gives you options and it gives you whatever. So this is the REST-based interface, right? We talked about 60 collections per metric. You can specify the time interval. The default is 1 minute. So what it's actually showing you with each of these measurements is the per second measurement for that specific metric. Okay. Next, I apologize because I always seem to forget that there are people in the back of the room when I make these slides. But the next thing we're going to cover is CB stats. Okay. Who here has used CB stats? Just a quick show of hands. Just a handful of you. Okay. Cool. So CB stats is a really interesting tool. It hooks into what we call the EP engine or memcached side of things. If you've ever seen a Couchbase diagram, architectural diagram, it's on the memcached side of the house. But this is going to give you metrics for the memcached side of things, but not for anything cluster related or not for anything related to indexing or views or XDCR. So these are only memcached level metrics. Okay. It's a command line tool for viewing stats. There's a link to the doc for it here. And there's a lot of stats available. If we're just talking about metrics, there's 333 plus metrics that are available every single time you run CB stats. Okay? A lot of these fall into the category of, I think you'd agree, debugging level metrics, right? But there's a few gems in there in terms of like what you'll really want to pick out and focus on and get into your monitoring system. And so we'll talk about those in a bit as well. CB stats is a little bit tricky in the sense that there are what I call cumulative as well as snapshot-based metrics. Okay? Now, snapshot is something like memory usage, right? If I look at memory usage out of CB stats, it might tell me it's at 10 gigabyte. And I can look at that and understand it very easily. If I look at something like get commands or the number of reads that have been done, it'll give me a number that might say 336 billion. Okay? So that is a cumulative metric. It's actually showing you, exactly what it has. It's just doing an increment to give you that counter. So some of these, in terms of the cumulative metrics, you have to sometimes take a rate basis. So you have to do 2 collections of that metric and then subtract to get a per minute, per second, per 5-minute rate out of it. Hopefully that makes sense. Okay. So it's sometimes not always obvious, but a lot of the Couchbase specific operations are going to be cumulative. So CAS operations here, command get, any of the commands, these are all going to be cumulative. And then you have things like connections, which are obviously snapshots, right? So it is somewhat intuitive at times. So an example of how we might go about using these metrics. One of the things that we do in Couchbase before going to production is we size clusters. And sizing is if you have gone to any of the production tuning or production health talks, sizing is pretty much one of the most critical things in terms of going live with Couchbase, right? And one of the questions we ask is, what is your average value size? Which doesn't make the most sense if you're asking a MySQL DBA, what's your average record size out of your 200 tables? It's a strange question, but it's something that we need to get. But we can actually figure this out from the metrics in Couchbase. We actually figure this out from a production side. We have metrics, 3 of them listed here: EP value size, cur items tot, and EP num non-resident. And these 3 metrics represent 1, the amount of RAM that Couchbase is using for this specific bucket to hold values. Okay? 2, the current items total on this node, both active and replica. And 3, the number of items whose values have been ejected from RAM and are no longer being held in RAM. They are going to be serviced from disk if they're requested. So the formula works out like EP value size over current items total minus the number of non-resident items. And we divide that, and that gives us an average value size of, in this case, for this example, 4.5 bytes, or 4.5K, if you will. Okay? So this is interesting because later on you can use this in completely different ways. One example, a customer that I had an issue with interface saturation. Right? They didn't know it was interface saturation at the time. All they know was that their client is sending a request to Couchbase and those requests aren't coming back. And what we're able to figure out is from the average value size and from the number of gets they're doing, we can actually math out exactly how much bandwidth utilization is being done on a per second basis and figure out that this is why the application's not responding like it should. Your network is not sized properly. Okay? So a lot of interesting things that you can do from a stats perspective. This is just one quick example of sizing. Okay, so you guys also probably cannot read this either, but these slides will be online later. This is an important thing for the CB stats command. It runs against both an IP as well as against a port. Okay, and here you can see I'm running it on the same host on 2 different ports, and I'm grepping out a couple of the normal metrics: memory usage, the number of active vBuckets, and the number of active items. Okay? And you'll see we're getting completely different numbers here, right? in terms of memory usage, in terms of these VB active num is the number of active vbuckets. But the reason is that when I hit port 11211, that port is Moxie. It's our memcached proxy. And what that does is it actually sends it out to the entire cluster. So from CB stats, you're able to get metrics not only on a per node basis for a given bucket, but you're also able to get cluster-wide metrics if you're interested in that from a collection standpoint. All right, timings is kind of an interesting one. Couchbase provides timings for a lot of internal operations. And those internal operations are obviously relevant to what you're doing in terms of servicing data. But again, there is kind of a docs link here for you. And some of the common operations that might be of interest to you guys are, how long is Couchbase taking to service a GET request? How long is it taking to commit something to disk? How long is it taking to fetch something off of disk? And so all of these things are enumerated in the CB stats timings. And the way you read this, and I'm not going to point anymore. The way you read this histogram is that there have been 64 million GET operations done since the last statistics reset. Of those 3 million, whatever, 99.99% of them were serviced by the engine in under 1 millisecond. Right? I'm looking at this number right here. And then of those 64 million, we have another, I don't know, I'm bad at math, let's say 5,000. That took anywhere from 1 millisecond to 16 millisecond to service. Okay? Now, from an engine perspective, you can actually see that most of those requests, if you look at the 98th percentile, 98% of them were serviced, let's say, under 16 microseconds. Okay? And that's mainly because it's an in-memory hash map lookup that we're doing the bulk of the time. But in this case, this cluster is sized so that not all the data lives on disk. So we can actually see, for those requests that hit disk, how many were there, how long did it actually take? And that's one of the things that's actually interesting when you start using Couchbase at scale. You'll see that network becomes the boundary for a lot of things because the response time from the engine is in the double-digit microseconds. So the rest of the time in terms of response time for the application to actually read or write something is in network transport. Okay, so nickel queries, that's also something that is enumerated from a REST endpoint. I should have organized this a little bit differently, but here you have an example of me hitting the REST endpoint on a query node. And what it's doing is it's showing me some of the more interesting metrics that are coming out of the query server. Things like the number of requests per second, the kind of 99th percentile time. And I'm doing this on a system that was running a load generator, and it's a single node system. So that's why it's got somewhat high 99th percentile query times. But that's the magic you get when you do your demo slides an hour before your talk. So good metrics here as well. So metrics for key value, metrics for the REST endpoint, metrics for XDCR and indexing. All of those are covered from the Couchbase side. For the next 5 minutes, I'm going to talk about some of these quick ones. These are some of the tools that I use a lot when I'm taking a look at a system, making sure that it is going to perform as expected. HTOP is one of those. HTOP gives me a fantastic view of what's going on with this system. I like that it gives me core utilization. If I've got an 8-core system and I'm CPU bound, but I can see that this process is single-threaded and it's just bound on one CPU core, I can take steps to see what I can do to parallelize it, right? So it provides me fantastic options for getting a better sense of the data of what's going on. I can see how many threads are going on with it. It's very customizable. I can easily sort by RAM or any of those different aspects that I'm looking at. Whatever it is you use, HTOP, top, VMstat, looking at the raw proc files, if that's what you like. Those are all options. It's just so long as you look at something, right? IOStat is also something that I look at a lot. I look at it primarily to get an indication of whether or not the IO subsystem is fully utilized, okay? And I use that in my decision-making process for, how good is this system in terms of I/O capacity? Is it maxed out or can it handle more? Okay. And so when you're looking at I/O stat, there's a couple things here that you want to look at. One is the percentage utilization for the device itself. The other is perhaps the queue size. And Michael will talk about queue sizes in a little bit. Okay. Here's an example with slightly higher average queue sizes. But again, we're going to look at something a little bit more impressive a little bit later. So we want to make sure that I'm not utilizing all the I/O capacity, that the weight for those I/O requests is not too high, and that I have capacity to service the read and write requests that I'm doing. Okay. Last thing that I'm going to talk about for a little bit is IFTop. Again, this is a fantastic tool. If you don't have systems monitoring in place like a Cacti or a Ganglia or something that shows you more than just how much CPU you're using or how much free RAM there is, IFTop is also something that's fantastic that you can very quickly install. I use it to see what interface utilization is like. I'm one of those guys that is more of a trust but verify, right? So if someone tells me, hey, you have 10 gig interfaces on this machine, most likely what I'll do is I'll say, that's great, thank you, and then install IFTop as well as iPerf or something that will drive load and use it to actually verify that I have that much bandwidth available to me and check ping times and all sorts of things. It's also fantastic for showing you where your traffic is coming from and seeing how much is being used.
All right, so Alex has shown us a lot of really cool tools to get data out of your Couchbase server and the application. But what do we go and do with that? Like, we've got these metrics, how do we go and alert, how do we go and respond to that? So I want to sort of deep dive into sort of 4 distinct areas in how we look at the statistics. So firstly, from the actual Couchbase server itself, the actual application, the client application metrics, and then look at the disk and network utilization with a few more sort of real-world examples. So as Alex showed, when you log into the Couchbase web console, you get this pretty sort of solid overview of key metrics on your cluster. So you have your ops, your gets, your sets. The cache miss ratio is certainly something that may be of interest to you. Active docs resident, is everything that you're storing in RAM? How many items do you have? How much memory you've used? And the disk write queue is also another really interesting metric. So when it comes to monitoring, a lot of how we monitor at LinkedIn is we have a base set of metrics that we want to monitor and alert on, and then we'll allow you to opt in or opt out of certain metrics depending on what you're using Couchbase for. So if you've got highly ephemeral data that's changing all the time, we really don't care about number of replicas of your data. If it's something that's extremely write heavy and in sort of offline sense, we probably don't care about disk queue as much. But there are a few things we do generally care about pretty consistently. So number of operations, are we actually driving traffic to this cluster? If I've got 0 operations incoming to my cluster, something's probably broken that I should know about. Cache misses are the next one. So it depends on how you're using your Couchbase cluster, whether you want to alert on this or not. If you've got one application using one bucket in Couchbase, you probably do care about your cache hit or cache miss ratio. Are we getting that in memory or are we going back to disk? One thing, key thing to keep in mind, that if you've got multiple client applications calling the one Couchbase bucket, that cache miss rate sort of becomes not unreliable, but it can be potentially misleading. And it's generally better to go and look at that metric from the client side because the use cases are for hitting or missing the cache now a sort of client-side concern more than a server-side concern. Active and replica buckets, we always want this to be 1024. If it's not 1024, something's probably wrong with your cluster. Percentage of items in memory. So for our use case at LinkedIn, we want this to be 100%. We want to make sure that all of our items are in memory. We don't like ejecting to disk. But again, that depends on your use case of Couchbase. Disk queue. So this is something that Alex touched on earlier. So there are a couple of key disk queue metrics. So you have number of items that are currently in the queue, and you also have drain and fill rates. So generally, if I want to get alerted on something to do with the disk queue, I'll start with this disk queue items metric. If I then have to go and do some extra troubleshooting, I might look at the drain and fill rates to sort of get a better understanding of what's actually going on in my box. The other interesting metric that we like at LinkedIn is misdirected requests, so other requests going to the right V bucket. And we've actually put some auto remediation in place where if we get hits on this metric where we know that requests are going to the wrong V bucket, we can actually sort of reset the Couchbase client and get it to pull down the V bucket mapping again and start sending requests to the right V buckets. So let's look at the Couchbase client metrics. So for us, there's a couple of key things to consider. Obviously, you're looking at call counts, but call time latencies, and you can get these separately from gets and sets. So generally, you do not want to measure gets and sets as the same metric because it can be misleading. If you're doing large gets or large sets, you might not be always getting what you expect. The cache hit ratio. So is the hit rate what you expect? It depends on your use case of Couchbase, and as someone who operates Couchbase clusters and operates applications that use Couchbase clusters, you should have a rough understanding of how that application uses the cluster or the bucket, and what sort of hit rate are you expecting. And then also the error metrics. So are we getting timeouts, retrieving objects? Are we even able to talk to Couchbase Server? And in the Java 2.2 SDK, Couchbase actually natively emits these metrics via the event bus, and I've got the link there that you can get some more details on. So this is what monitoring these client metrics looks like at LinkedIn. So this is across multiple data centers. So I've got my, these are the get metrics. So I've got the get call count total. The call time average, you can see that's really low, except there was a little blip at 1600 yesterday. I have no errors, which is cool, and my hit rate, it sort of varies, but in this particular use case, I'm not overly concerned with the hit rate. It's not something that's key to the performance of my application. So let's look at disk. So there are two sort of key areas where you have to think about your disk. So one is disk utilization or disk space, and then the second is disk I/O. So consider if you have a say a 5-node cluster. Couchbase, what gets written on disk gets fragmented, and Couchbase will periodically go and compact this. You want to make sure that you have enough disk space so that you do not run out of disk before that compaction happens. And depending on how many writes you're doing, this can be a larger or smaller concern. The other problem is if you have a 5-node cluster and you lose a node and you need to rebalance, you're going to have more data incoming to that node. So you've got to make sure you have that headroom to take the extra data in disk if you need to fail out a node of the cluster. So disk I/O. So Alex talked about some really cool metrics before, but how do we sort of look at this in a more real-world way? So at LinkedIn, we have a number of high write-intensive applications with Couchbase, where we may be writing up to a million, doing 1 million sets a second, which is a huge amount. So we want to make sure that if we're writing to disk, that number one, we can sustain the IOPS load. So if we're doing 1 million writes per second, It's probably something that spindle disks cannot do. And so for those use cases, we actually use SSDs to make sure that we don't back up the disk queue. And then secondly, the disk queue. So this particular graph I've got here is for the Bezo Encryptor Couchbase bucket at LinkedIn. So this bucket has a service writing to it periodically, doing 4 or 5 million writes in a given small amount of time. And you can see that disk queue sort of builds up for a period of time. And so again, this comes back to understanding how you're using, how your application is using Couchbase. In this particular use case, the number of items in the queue being 1 million is fine. It's not a massive concern for us. But in some other applications, this may be a problem. And of course, this can also, these metrics can be like a precursor to seeing degraded disk performance or disk failing. So I want to talk about the network metrics. So a couple of obvious things. So number one is network connectivity. Secondly is the connections and how you're using the connections on the Couchbase server. Then talk about the capacity and utilization of the cluster. So obviously, we want to make sure that our server is actually available. Can we ping it? The second thing is firewalls. Couchbase actually uses a number of different ports, depending on what version you're using and some of the features that you're using in Couchbase. But if you're going to be using Couchbase in a firewalled environment, you want to make sure that you have all the ports that you need opened up, and I've got the link there to the official list. Second thing is connections. So you want to make sure that you're not going to hit your file descriptor limits. This should probably never happen, but you do want to be sort of aware of how many client applications there may be trying to connect to your Couchbase bucket or your Couchbase server. We actually have a use case at LinkedIn where we need 30,000 connections open at one point in time. So we actually do care about this. The other thing to look at is connections in closed wait state. So I've got this graph here, which is basically a histogram, and it's, I believe, a percentage-based, in percentage, which shows all of the TCP connections and the state that they're in. So you see the large amount of purple, which is the established percentage. So we've got 80% of them that are established, which is pretty cool. And then we've got some listen, and we've got some in, we've got a small amount, very small amount in closed wait. Sometimes you can see if your Couchbase cluster is in distress, closed wait metric, number of sockets in closed wait state goes high, and it sort of is a good visual indicator that something's not quite right. Last point I want to make on statistics is network capacity and utilization. So you may have a 1 gigabit link or a 10 gigabit link. That's cool. But the practical actual capacity that you're going to get in a typical network is 85, 90% of that, before you do any tuning. So, always keep that in mind. Certainly, we've seen in the past when we've had congested networks or congested interfaces, those read times become much slower. And basically your cache will sort of get to a point where it's slow enough where it's affecting your application's performance. So obviously you'll get higher latency on responses and you'll get slower replication, which may or may not be a concern. So here's a graph of one of our Couchbase clusters at LinkedIn. So the incoming traffic is fairly low, but we are doing 50 megabytes out of the interface. And the way we do this is we collect the statistics from /procnetdev every minute and then emit that into our metrics system. Again, looking at capacity and utilization, it's sort of important to have a rough go at estimating, how much capacity you need in the network. So as Alex said before, it's super important to, work out how much traffic you're expecting to the cluster, and what are the object sizes, etc. And we've got a nice simple table here where we actually go and work out how much reading and how much writing we're doing. And you can go and use something like CB workload gen to go and replicate this in a pre-production environment and make sure that you've got the right capacity, or network capacity for your Couchbase cluster. So Alex is now going to talk about a few of the external monitoring integrations that exist for Couchbase Server.
All right, thanks. So over the course of time, there's been a number of customers that have integrated Couchbase into a variety of different things. And this is actually just a couple examples, right? Some are, pretty industry standard. Some you may have never heard of, but it just kind of depends on what you're looking to get out of it, right? So again, going back to what we talked about before, Couchbase is not a monitoring system in the sense that if something goes over a certain threshold, that it's going to reach out and actually notify you about it. There's some basic level of alerting built in to Couchbase, but it's by no means a full-fledged monitoring system. So, here if we look at some of the common examples, they're all going to be kind of slightly different in terms of their ease of use and kind of what they expose and their actual value. So, Nagios is pretty much an eventing system. You can capture some performance metrics into it in the form of, it stores them as RDs, but it's not, if you take a look at it from Couchbase monitoring standpoint and then Nagios standpoint, they're worlds apart, right? Things like Xenos or Hyperic are much better in terms of representing the full stack, not only your Couchbase cluster nodes, but as well, what's going on at the virtualization layer, at the OS level, at the network level, at the app tier, so that you can correlate all these metrics and get a sense for what's going on. Companies like Avalon have worked to create monitoring for Couchbase itself. Places like Datadog offer it as well. And there's some things, I think New Relic and AppDynamics both have a REST-based interface for sucking in metrics. And so both of those can also easily be used to integrate Couchbase into their system. So, your monitoring system may not specifically be covered in here, but the one thing to understand is that for a monitoring system to capture anything, it needs to be programmatically accessible, right? That piece of data. Whatever it is that you're going for, how many queries per second am I doing? What's the memory usage? What's the disk drain rate? I need some kind of way to programmatically get that information. And that's typically how all monitoring systems work. They don't come out of the box monitoring every single thing. They get packs, monitoring packs or plugins or extensions written for them that tie in with a given vendor's exposed interfaces. Okay? So Michael's going to walk you through one side of the interface house, the REST side. I'll walk you through the CB stat side. We have a couple quick examples for you guys on what that kind of looks like.
All right, so I've got two examples, and I've got the links there if you want to bring them up on your laptops. So the first one is Datadogs. I really like Datadogs as a product, and their agent that they've written is fairly extensive, which is pretty cool. For the purposes of this presentation, I've written a super simple stats collector, which I've got a link to a gist on GitHub. So a sort of a precursor warning, do not run this code in production. It's not, there's no defensive programming in here. The purposes of it is to sort of walk through the basics of how to go and monitor a Couchbase host. So we start with a main function and we create a loop and we get the start time of the loop. And so for the purposes of this presentation, I basically want to go and emit a set of metrics every 60 seconds. So I grab the start time of this loop. So we need to go and know what buckets are on that host. So we go and get buckets. So what does that look like? So I'm running this daemon from localhost, so I go to this URL, and it gives me basically a list of buckets, which I yield back. And then what I go and do is for each one of those buckets, I go and gather and emit the metric for that bucket name. So I go to that API endpoint that Alex was talking about before, /pools, default, buckets, the bucket name, and then stats. You can also get additional stats for XDCR, nickel queries, etc., using similar methods, which he's got a link to. And then so I iterate over the stat name and stat value for bucket stats. And you see in the tree diagram we had before of the JSON, it's under op samples. And then I go and emit the metric. So I've written this sort of pseudo emit metrics function. So I have the fully qualified domain name of the host, the bucket name, the stat name, and then the stat values. So I'm going to emit all 60 metrics for the minute. Then going back to the example, this might take, say, 2-3 seconds. I want to go and sleep for the next 57 seconds. So I'll go and work out how much time my function took, and then sleep for the rest of that minute. So Alex will now talk about how to do this with cbstats and bash.
Right. I love bash scripts. So there's a couple different monitoring systems in terms of, they all differ in terms of how they suck in metrics, obviously. One that I'm familiar with accepts things in key value pairs, okay? So what it's looking for is a metric name and a value. You tie that in with the script, an XML descriptor, and the descriptor pretty much has all the metric names and typing for the metrics. So it tells it, hey, there's a percentage, there's a timestamp, this is whatever. But for that monitoring system to work, I need to get my Couchbase metrics into a key value pair format. Now, the output of cbstats is fairly close, but it's slightly different than what this monitoring system is expecting. So Couchbase from cbstats emits out the metric name, a colon, a very large set of tabs, and then an actual value. So what I want to do is not flood the monitoring system with every single metric, because remember, out of those 333, there's some gems in there that I want to collect. So I want to be a bit more specific so that what I have in the monitoring system is what I care about. And so what this script does is it does a couple things, right? First, what it's doing is it's creating a temporary stats file on disk. And it's running cbstats all against the local host, against the memcached port, against the bucket name that you specify, dumping it to this file. From there, I'm looking for some specific metrics, and this is double-lined. It's appended because PowerPoint got in the way and it wanted to wrap. So I'm looking for things like the bucket allocation, right? The actual memory usage, the percentage of data that lives in the active in RAM for the active vbuckets as well as the replica, the number of ejections that have been done for active and replica, and the disk write queue size, okay? And so what it's gonna do is for each one of those metrics, it's just gonna grep through that stats file form, and it's gonna do a sed, swapping out colons for commas, right? And then strip out all the spaces, and that is gonna be enough to give me output that looks like this, that I can suck into my monitoring tool. And again, remember, your monitoring tool may want things in a different format. The point of this, again, is to just simply show programmatically this is how I might get that data, massage it in just slightly different format, okay? All right, so to finish off, Michael?
Yeah, so number one, it's important to have monitoring in place. I can't stress that enough. Like if you're running anything in production, you should always have monitoring in it. Second thing is understanding the metrics you monitor. One challenge we face at LinkedIn is we have a lot of metrics for our systems, and that is super cool. Don't get me wrong, but it's equally important to understand what those metrics actually represent and how that affects the performance of your application. So as I sort of mentioned before, understand what your use case of Couchbase is. As I said, you might have multiple applications talking to the one bucket with all sort of different use cases and requirements, so it's important to understand them. And then again, understand what these metrics are, what causes them, how do you get into this state, and then how to remediate them. And you'll find plenty of good information in the Couchbase documentation on many of these use cases. And I think that wraps it up.
Yeah.
Thank you very much.
Yeah, thank you guys. Any questions from anyone, or?
Bryce.
I can't see its lights.
Yeah.
So you're spewing out a bunch of metrics, but some of those are gauges and some of those are counters. If you want to go the R&D terminology, how do you know the difference between the two? Is that documented anywhere? I haven't come across that.
So, like, obviously for LinkedIn, we keep a map of what we consider gauges and what we
figured it out, but I don't know.
So internally we know. Do you have documentation for that?
We do not have documentation for it. I've taken a crack at writing some of this stuff up. I'll actually send it over to you guys. But it outlines some of the key metrics, and I call them cumulative versus snapshot. You call them gauges and whatever. But the point is the same. It's can I trust this metric, or do I need to do some math to figure out a rate based on this?
Question down the front.
Yeah, so what do you guys do for logging? I mean, obviously you're wanting to track these metrics, but we also correlate our logs of net IDs or maybe error messages that Couchbase is providing us.
Right.
Does it also have that capability to output those logs?
So the question is, what do we do about logging? So specifically at LinkedIn, we don't ingest Couchbase logs, but there are logs in the application.
Yeah. It's generally not recommended to just try to watch the logs in Couchbase, because about 99.99999% of it is noise. It's debugging level information that our engineers use to troubleshoot a distributed system that's sometimes replicating to things in other data centers. So there's a lot of information in there, but it's not done in a way that's consumable easily by something like a Splunk. That, and it gets, Splunk is tied to gigabyte cost for indexing, and our logs get kind of voluminous.
Is there a informational versus an error?
Yeah, so there's both. What I would actually suggest if you wanted to get event-type log messages is the REST API does expose something for logs itself. You can actually see it in the UI. And that is something, if you're going to pull anything log-related in, that is what I would start with. Right, so there'll be an endpoint for that from the logging standpoint. You can actually see, some of the more important things like, rebalance completed, or failed over a node, or auto failed over something. Those kinds of messages are typically found in there, and they're higher level messages.
Okay.
All right.
Okay.
Thank you very much.
Thank you, everyone.
And enjoy the rest of your evening.